So maybe you've heard about IoT, or maybe you've read about it and you have a good idea of what it entails, or maybe you haven't. Either way, we'll not only cover everything you need to know in this course, but everything you need to understand to either build an IoT operation or business, be a value contributing member of an IoT strategy, operations, or technical team, or even be able to commercialize an IoT operation as a new revenue stream. We'll start with the fundamentals, where we'll cover IoT as a concept, its applications, as well as what the infrastructure looks like and the various components required. This course mainly focuses on the commercialization side of things, that is, how to build a commercial operation around IoT. So as much as we'll go into quite a bit of detail on the technical side of things, that's not the focus here. We're all about leveraging opportunities, so that's the tone we'll take throughout this course. Let's get going. So how do we define IoT? Well, we've defined it as a mechanism through which objects that speak the same language can digitally communicate with each other, as well as give information about themselves. So essentially, IoT is a set of components that set up the medium through which objects, typically objects that have no other means to digitally communicate. There are various mediums, what we have come to call networks, through which different objects can communicate. Some objects, such as phones and smart TVs, come built in with a mechanism to digitally communicate, whereas others, such as cows perhaps, can communicate in other ways, but certainly not digitally. What is an object, you ask? Well, we've already referenced phones, TVs, and cows. Those are types of objects, and there are many others. Just look around you. Furniture, fruit, pets, and so on. Why would you want to talk to fruit, you ask? Wouldn't it be great if bananas let you know when they plan on going off? Or for avos to tell you how far they are in the ripening process? I doubt they appreciate being squeezed all the time. Imagine if your parents kept squeezing you to determine if you were full after a feeding. Not fun. That's what your neurological system is for. Your brain tells you you're full, so you push the bottle away. That's what IoT, combined with other advances such as AI and machine learning, aim to do. To eventually create networks that allow objects to self-learn, self-communicate, and self-correct when required. We'll make the distinction between connected and unconnected objects and devices throughout the course. This is important because, in our view, IoT's real value comes to life in contexts where unconnected objects are at the center. Connected objects refer to devices that have a built-in digital communication mechanism. These are typically electronic devices such as TVs and phones on the consumer electronics side of things, or mining machines or manufacturing equipment on the industrial side. Sometimes the same device can fall in both the connected and unconnected sides. A run-of-the-mill fridge is typically unconnected, but a smart fridge with a Wi-Fi stack, or shall we say a broadband connection mechanism for smart home applications, is a connected device. Your furniture, livestock, and so on are traditionally unconnected objects. So let's describe the various mediums for communicating as well as associated objects and devices. We are familiar with the mediums of digital communication we typically use in our day-to-day lives. Then we have specialized IoT networks that make it possible for unconnected objects to communicate. That's where we'll mainly focus in this course, how to set up such an operation, as well as the various commercial models around it. Now, let's get into the various communication mediums, associated objects, as well as the various business applications around them. Over and above broadband applications we typically use every day, there are many other uses for this network. The apps that are connected to our German cars use this network to communicate with our cars in a way that allows the dealerships maintaining our cars to treat them as a managed fleet. That in itself is an IoT application. The car collects information about its own mechanical health. In some instances, it may even collect information about your driving habits in a way that allows the dealership to blame you for negligence, as opposed to categorizing a fault as typical wear and tear they need to fix for free as part of the maintenance agreement. Let's move on to Wi-Fi. We all know how it works. Fundamentally, this network in itself acts as an intermediary network between actual physical networks and the devices that exist within them. It allows a connected device to act as a network itself to extend connectivity to other devices that speak the same language. It offers the possibility to control objects as well as allowing the said objects to communicate with each other for a range of lifestyle-enhancing applications for the consumer. Then we come to specialized networks. Once the onerous undertaking of setting up the infrastructure is done, there's a range of really exciting applications that can generate a lot of value for businesses as well as the consumer. Some of them are listed here. Cities can be able to monitor bus capacity and demand in real time and reroute buses accordingly. You can have concrete evidence on an app before you accuse your mother-in-law of rearranging your furniture while visiting in your absence. The possibilities are many. Okay, so what do your sensors measure and what kind of outputs do you get in each application? What is the required medium? That's what we cover next. You might want to monitor your fridge, especially if you're a business owner in a business where perishables are a difference between profit and big losses. You want to know if there's a risk of overfreezing on a cold day so that you can adjust the temperature accordingly. For more advanced applications, the fridge can self-adjust, but you would still like to know in case you put something in there temporarily, which might suffer from the temperature adjustment. Another type of measurement is coordinates, obviously for the end goal of monitoring location. Depending on the type of object, the IoT application could either involve an integrated sensor placed somewhere on the object, or it could be a chip embedded within the object if the said object is some type of electronic device. The most obvious output of location or movement measurement is for security purposes. That tends to be the main objective for non-connected objects. There are other applications, it just takes a bit of needs-driven innovation. For unconnected electronic devices, it mainly has to do with collecting usage behaviors as well as maintenance of the said devices themselves in some instances, such as monitoring of transmitters placed in remote places. In most instances, it's a matter of collecting and transmitting information that is already being collected within the device while operating. So there are a few options in terms of IoT applications mechanisms, all with varying complexities. Electronic devices are relatively far easier to deal with from an IoT application standpoint than general objects such as furniture. The main complexity comes in when the device is already manufactured unconnected in the market, particularly for consumer products. So it's easier to manufacture a newer, either connected or IoT-enabled device and incentivize consumers to replace the old, unconnected device. The desired outputs in this case are many. Advertising is the main driver in as far as consumer electronics is concerned. However, there are other business-to-business applications, particularly in relation to equipment performance monitoring and maintenance. There are many other types of objects and applications one can think of that could benefit from the sensor measurement, data collection, and analysis capability that IoT enables. For example, it wouldn't be such a bad thing for one's handicap scores and associated data to contain information relating to actual swing and swing speed relative to wind strength and direction at various holes across the course. It would certainly make the game more interesting. Now, let's move on to Chapter 1b, where we will go through the typical infrastructure of a specialized IoT network and how to set it up.